All right, welcome back to the Punny Math Teacher. I'm sure you've heard all about the quadratic formula because I've talked a lot about it. So we are going to be using twice this video as a length. Make sure you're pausing and actually making sure you're writing everything down and keeping all of your work straight so you can go back and read it, understand what steps you did, why and where, and all that jazz. So, we're now on our last thing. We're solving quadratics by quadratic formula. So you know everything on here. We haven't actually gone over the Pythagorean theorem, but we did use solving with the square root property, and we also did simplifying radicals, which would be used in the Pythagorean theorem. It's an example of a quadratic formula. It is a squared plus b squared equals c squared. So I'm sure you've seen that before and seen it in middle school. It's all good. That caret key, so just an FYI, that is C-A-R-E-T, that's the symbol. If you hit Shift 6, if you click caret, that represents an exponent. So those twos are represented as superscripts. That's why it's a squared plus b squared equals c squared. But those are quadratics because they're squares, and they're also radicals when you square root them. So it's actually something you already learned, but I didn't make explicit notes on it, but you know how to do it. So we are now working on quadratic formula. That is your last method in your choose your own adventure flowchart for how you would solve a quadratic function. So make sure when you're done with this, you update that and then go present it to somebody, whether it's someone else in your class or it's your math teacher. Go present it to your math teacher. They'll be so proud of you. Okay, table of contents. Last one, solve quadratics by quadratic formula. And then this notebook gets put away. Unless maybe I can use geometry notes in this. We'll see how many notes I got. That's probably for algebra 2 though. Okay, so solve quadratics by quadratic formula. I need a marker. That's what I want. Ooh, let's do light blue. We haven't done light blue. Okay, so this will work for all quadratics. Which remember, that means it has a degree of 2. So it works for all quadratics, but it's also not a waste of paper, but it takes a long time to do it, especially if you break it down every single step. So it's nice when you can combine steps together. So it's really nice for unfactorable ones, and here is your formula. And there are plenty of YouTube videos, I'm sure, out there of how it even came about, why it works. I can go over that, but not everyone would be interested. So we're just going to leave it at, boom, here's a formula. Make sure you memorize it. Okay, so in this formula, notice I'm using a lot of parentheses, all right? So this negative is going to take the opposite of whatever b value you have. Make sure this b is the base that you are then multiplying b multiplied by b. You're multiplying the negative for a and the c, and multiplying 2 and a. So remember that we are using this for ax squared plus bx plus c equals 0. So for all of these solving, even the graphing, you have to make sure that it's in standard form. So you know your a, your b, and your c. Everything relies on that. So make sure you know how to make it into standard form. So we're going to do 2 examples. So these first 2 are going to be, I hope I said 4 examples. The first 2 are going to be factorable, and then the last 2 will be unfactorable. So you'll see how nice the answers are for factorable ones, and how ugly they are for unfactorable, but we get an answer, and that's the goal. So, for example 1, you're going to have 2x squared minus 8x minus 24 equals 0, and example 2 will be x squared plus 2x plus 1 equals 0. All right, so we have to figure out what a, b, and c are. A is 2, b is negative 8, c is negative 24, and then stick it all in. So x is my variable, so this will be x. If this was like a p or a t or an s or something, then this variable would also change. So I have the opposite of negative 8 plus or minus the square root of negative 8 squared minus 4 multiplied by 2 multiplied by negative 24. And I'm going to change to a pen, I think, after this. And then 2 multiplied by 2. So pause here, make sure you can see and identify where all the A's went, all the B's, and all the C's. So I'm going to do this, I'll do this all in marker. And the next one I'll do in pen. Okay, so I can do, in one step, I can do a lot. So I'm going to write this fraction out. I'm going to do the opposite of negative 8, so that's positive 8. Plus or minus, I can also do the 2 plus 2, and that's 4. Now I'm going to look at my square root. Okay, I'm not going to do everything. I'm just going to do those two terms. Remember, from radical operations, I think it was page 47, that we did this. So negative 8 multiplied by another negative 8 is a positive 64. This is a big mistake that people make a lot. People make this as negative 64. It's not. It is a negative 8 multiplied by another negative 8, which makes a positive 64. So watch what you're multiplying and use those parentheses. And then negative times a negative is a positive. 4 times 2 is 8. 8 times 20 is 160. 8 times 4 is 32. So 160 plus 32 is 192. 192. All right. So if I've taken this huge formula and all this fraction stuff and I go whoosh. All right, it's half its size now, which is awesome. And now I can do 8 plus or minus 64 plus 192. That would be a 6. That would be 15. And that would be 256 over 4. I know the square root of 256, that's 16. So I get 8 plus or minus 16 over 4. I'm now going to split it up. So I'm going to get 8 plus 16 divided by 4, and then 8 minus 16 divided by 4. Remember that plus or minus lets us do shared work for a while, but then I have to split it up because now is the time to actually simplify it. 8 plus 16 is 24. 24 divided by 4 is 6. So x equals 6. 8 minus 16 is negative 8. Negative 8 divided by 4 is negative 2. So x equals negative 2. All right. So if you want to draw more work, go for it. If you want to do it verbally out loud, that helps you, go for it. But notice that I'm writing enough work that someone can then take from here and say, yes, that's where the negative 2 came from. They can work backwards and see exactly what process and logic I was using. You're communicating to someone else what you're doing. So if you can go from here and boom, already know it's 256, well then go you. That's totally fine if you want to skip writing this step, but you're still writing a next step so someone can follow and see where you went incorrect or just how you did it, because people are going to learn from your work and how you're explaining your reasoning. All right. So I'll still do it with marker. It was fine. Okay, example 2, so x equals negative b plus or minus the square root b squared minus 4 times a times c, all divided by 2a. Try it on your own, all right? So I'm going to have the opposite of 2 plus or minus square root 4 minus 4 is 0 all over 2. Okay, so I actually can skip this line because I know what the square root of 0 is, so I can just go floop right there. Because I actually skipped this line, I guess is what I did. So I'm going to have negative 2 plus or minus 0 over 2, which is plus or minus 0. It does nothing. It's not going to change my value. So this means that x equals negative 1, and it only has one solution. That's okay, okay? So sometimes you will get 0 solutions, you might get 1 solution, and you might get 2 solutions. I don't think any of these have no solution because that gets into complex numbers and different things. But I guess I should probably sketch those over here, that there are 3 different versions of a quadratic you could get. You could get one that, like we did at the beginning, that crosses the x-axis 2 different times, like example 1. Or it could cross the x-axis at one place, which is like example 2, but then I don't think we have an example like this. But what if we moved that graph up so high it just never crosses the x-axis, and now there aren't any x-intercepts? So you could get 0, 1, or 2. Those are the only options of solutions. Also notice for factorable ones, they're nice numbers. So the ugly numbers come when they're unfactorable. Yay! So example 3 is going to be 2x squared minus 14x minus 13 equals 0. And example 4 will be x squared plus 4x equals negative 5. So again, this is in standard form already, so we can find our A, our B, and our C. So I'm just going to stick stuff in. Opposite of negative 14 plus or minus the square root of negative 14 squared minus 4 times A times C. It's 13. all divided by 2a. Pause it, try it on your own. Okay, so let's say 14 plus or minus, it's all going to be over 4. That is going to be 196. Again, know your perfect squares. Positive, because it's 2 negatives. 4 times 2 is 8. 80 plus 24 is a 104. Okay, and so this is going to be 14 plus or minus the square root of, that'd be 200, 300. And that'll be 4. Now, simplifying radicals, this 300 gives me 10 square roots of 3. Pause the video, think about it. How did I go from square root of 300 to 10 square roots of 3? Go back to that simplifying radicals, make your factor tree, see what happens. Now, we have all of these terms or coefficients on our terms, 14, 10, and 4. They're all even, so 2 goes into them. So I could actually simplify this further and say this. Okay, now if I split these up, it's not going to get any simpler. I'm going to be stuck with 7 plus 5 square roots of 3 over 2 and 7 minus 5 square roots of 3 over 2. I can't make that look prettier. So sometimes your teacher may want you to break them up and list them out separately, or they'll just leave it like this because they know that you know this is just representing 2 different ugly terms. So these are 2 different ugly answers, but we can write them as one together because it has a plus or minus sign on it. So, yay, go for ugly. Okay, so example 4. Now this one's not in standard form, so I'm going to have to eliminate that negative 5. So now I'm going to get x squared plus 4x plus 5 equals 0. Now it's in standard form. I have an a, a b, and a c, so don't just count this negative 5 as your c. By eliminating the negative 5, your c ends up being positive 5, so just watch out for that. When I do my quadratic, the opposite of 4 plus or minus the square root of b squared minus 4 times a times c all over 2a. Negative 4 plus or minus 16 minus 20 is a negative 4. Oh, okay, so I did put a no example in here. Okay, now this is something beyond you, but because it's a negative 4, we can't take the square root of a negative. There's no way you can give me 2 numbers that are the same that multiply to make a negative 4. Okay? Now you can get 2 and 2, but positive 2 squared makes positive 4. Negative 2 squared makes positive 4. So there's no way to get 2 of the exact same number to multiply to make a negative 4. So that is my x. Now, if you are in Algebra 2 and you move on to this farther, we could actually simplify this to make it look better. That's the only reason why we would do this, is to make it look better. So we could make it look better like that, where I is the square root of negative 1. You can go Google it more about complex numbers, but this would then be your answer. But at the same, because that is what x is, but you can't have square roots of negative 4s, so your real answer would be there are no real roots. That's your real answer. So it's like that, this quadratic up here, this parabola that's above the x-axis and has no x-intercepts at all. So it has imaginary ones. Those are complex numbers. Because they're imaginary, they are not real. So if you want to go into Algebra 2, well, you probably will, but as you go to Algebra 2 or you want to explore those videos on my website, you're welcome to go look at them, but these have no real roots. So, yeah, we're good to go! I think Algebra 2 goes over it. If not, like pre-calc and trig stuff should. So, yep, that's it. And you already have gone over your adventure flowchart for how to solve. So this is your last thing to add on to that flowchart. Thank you for watching and have a great day. And hopefully summer, if this is the right time of year in life for you to go to summer break. So, woohoo! Thank you for watching. Have a great day. Bye.